In the modern world, we depend on electrical power to make everything work for us. But 78% of the world's electricity comes from the consumption of fossil or nuclear fuels, with less than a quarter coming from sustainable sources like wind, water, and solar. Unfortunately, there are times when the wind doesn't blow, the water doesn't flow, and the sun isn't shining, yet we still need power. Batteries provide that power, but even our best batteries cannot compete with the performance of fossil fuels. The world needs better options, and that's where we come in.
I'm Tiara Anderson, math teacher at Purcell Marian High School.
And I'm Michael Sullivan, STEM teacher at Princeton High School.
During this summer, we had the awesome opportunity to participate in the 2017 Research Experience for Teachers, in partnership with the University of Cincinnati and sponsored by the National Science Foundation. Our research goal was to develop better ways to manage sustainable energy.
The lithium-ion battery is our go-to energy storage solution for laptops, phones, and gadgets, but it is not yet our solution for transportation or grid power.
We still rely on gasoline to move around, coal power to heat our homes, and diesel to power heavy machinery. But what if there were a battery with enough capacity to replace the use of fossil fuels? The lithium-sulfur battery stores 4 times the energy of the lithium-ion battery. Also, sulfur is abundant in nature, low in cost, and safe for the environment. But the lithium-sulfur battery is not yet a reality. UC's NanoWorld is looking to change that.
We assembled a lithium-sulfur battery using high-tech lab equipment such as lasers, reactors, and microscopes that can magnify an image 30,000 times.
While our research focused on energy storage, my unit takes a different approach. My 9th grade Integrated Math 1 students will investigate conserving electrical energy to manage sustainable energy. Understanding most of electricity comes from coal, students will form the essential question, how can I use math to conserve my cell phone battery life and limit the waste of fossil fuel? It is my hope that students embrace the importance of being responsible energy consumers. Students will use mathematical evidence to create and support 3 strategies the student population can use to conserve the battery life of their cell phones. Using the engineering design process, they will conduct a school-wide survey to gather information to inform their strategies, then test and refine them using mathematics to analyze their data.
At Princeton High School, my 11th grade STEM students will address the energy access problem by designing small generators that do not rely on fossil fuels. They'll have to discover existing solutions, come up with new ideas, defend the best idea, build a prototype, collect and analyze data on their prototype, and then they'll get a chance to make their design even better by continuing once more through the engineering design process. At the end, they'll make a Kickstarter-type video to showcase what they've learned. We would like to thank the RET program and the entire team at UC's NanoWorld for providing us the opportunity to bring cutting-edge research into our schools.